that, well, I'm dealing with an AI that's based off a shape base. I'm dealing with a net connection, a game connection that's based off a net connection. And you'll realize that, okay, I know the function has to be either here or here. Unfortunately, sometimes finding a function can get a little tricky because you're like, well, where is it? And that's the reason I provide the SDK, so you can do a find on the document and see what grouping the function is in. So let's go back to our AI player, and let's say, let me undo here. Let's say we want to debug the death code. For whatever reason, we think we have a bug in it. So we set a breakpoint, and we hit run. You'll have to pardon my computer. It's a little sluggish. So we're going to say launch dedicated no. Come on. Now, this is a Windows form, and I'll show you how that works as well. So, I mean, it's... you can do whatever you want there. Alright, so we're just going to hit play, go. For testing purposes, I've written some helper functions to create like a sample AI, for example. So we're going to bring up the console here and say create AI, and we'll just create 25 just for this purpose. Audio done. Alright, so an AI died. And as you can tell, it hit the console breakpoint. And at this point, we can step through here and we can actually look at things and say, oh wow, the AI manager ID is 4881. Is it an object? Yes. So, you can, and then you can even do things like this. And say, I want to see a watch. And you can put a watch on something. We can, we go through here and we can say the item, we can see item is the lurker. And, we can see weapon slot is 0, what the player ID is, so forth and so on. And we can literally step right through this code. We're in a toss patch. Well, let's see what that does. We hit F11, and now we're in the toss patch function. So, we can see that we're creating a console.call class name, which would be the same as saying item data ::create item, and then parentheses health kit patch. And then you would have, we're setting a variable item, the item .isTemp to true. So forth and so on. And as you can go, we add the item to the cleanup. So SimSet, you can push to back, pop from front, so forth and so on. They're all available. As you can see, this is a 0.3f. I call it vec. And you can see I'm creating a new 0.3f, and I'm passing in the x, y, and the coordinates. Then I'm calling the vector scale. I get the shape-based .get I vector of the object. Figure out the dot product, figure out the velocity, set the transform, call schedule pop, and I return the item. End of story. And you can play. I'm playing a death cry. So what's going on there? Oh, it just says play audio, and it does that, and so forth and so on, until it goes through and sets a schedule. And you can either set a schedule up this way, where it's based off of the sim object, as in player, or you can use the other syntax, which is util.schedule, which, let's see if I can find that. Util.schedule. Right there. You can see util.schedule. So you have both syntaxes available, whichever way you prefer. In this case, I used a sim object.schedule. And then I schedule a delete me, and I'm tracking how many AIs are in the game at any given time. And then we could put a breakpoint here, hit run. Oh, another AI died, so let's just let it go. Alright, so now it's hitting the delete me, and this is doing the cleanup on the bodies and so forth. So we can continue to keep putting breakpoints in. So we can say, well, let's see what happens at apply damage. We're seeing that it's applying damage, and we can see that it's applying 14.77 points of damage. And then here you can see that I'm calculating the eject velocity. Basically, this was my way of making the AI seem like they're jumping out of the way. I just kind of stole the code from the vehicle when you eject out of a vehicle and modified it with a little bit less numbers to have it make the AI appear to be jumping out of the way of any more rounds. And then I apply the impulse, and I get the current position of the AI player, and I'm going to make them move within 10, move out of the way. So they're going to set their move destination out of the way. So they're not going to stand there and let you shoot them. They're going to dodge around. And then based on so there you go there. So let's say I want to see, I don't know. I mean, we can say, well, let's check this code, the get nearest player. So we could put a breakpoint here, and we hit the code. So if it's a player, so it is an object. So we're getting the position of the bot. So there you go, the bot position, the X, Y, and Z. And then what this is going to do is get me players around, and the players around this are these fellas. They're the IDs and the distance. And then we're going to enumerate through each of those players around. And if it's an object, if it's not equal to dead, if we want to look, so I assign a variable called team. So if we want to look at that, we could say add watch. That team is 1, and the team of who he's looking at is 1. So it's going to hit that and continue. So in this case, let's refresh. They're on opposite teams. It's going to say, hey, the nearest guy that I can attack is 4905. It returns that. It steps out. And we're into my code where I'm deciding, to check for enemy. So it found a player. The nearest player is not equal to -1. It figures out the distance. The distance is less than 30. So it's going to say transform T equals the get transform. So if we want to look at T here, we can see that the angle, rotation, and the position, which is the same. And then we say, well, what's the current weapon? The current weapon the bot is using is the lurker grenade launcher image. If the distance is greater than 25, it's not. So we're going to set the current weapon to the machine gun. And then we're going to turn we're going to mount the machine gun. This is just a flag I use to make the guy sit still. Then we check line of sight. If there's line of sight, we're turning on the bolt trigger. We turn off the trigger. And then we set move destination if the distance is greater than 10. And so forth and so on. And the end result is we end up with, dying, to put it mildly. So we can sit here. They're not real friendly. And they're, this is all 25. On our test server, we have 100 AI running around. And the average lifespan is about 5 seconds, average. And if we wanted to see metrics, we're getting 52 per second, which is respectable, considering we're running this in debug mode inside of Visual Studio. At any come over, pause, and then fire it back up. So, Visual Studio environment that we're all used to, except that we have torque in it now. The other thing that's you might say, okay, so we got all the scripts. The scripts make sense. Well, how do we embed this whole thing on that form to make it, make it look like it's running in the form? So if we come here to our main window, let's view code. What we do is we set up some basic things. On the main window load, we trap on the resize and on the close. I then prompt, do you want to load it in dedicated mode or not? If the user wants to load it in dedicated mode, it basically, think of it as command line args. We create a new .NET Torque object, and we call initialize. And initialize, we pass any parameters that we might want to pass along. The first set of this first array of objects are the parameters that will be passed to Torque's engine. So in this case, we're saying dedicated. The mission is level.deathballdesert.mission. Then the next parameters are the name of the DLL. The first one is the name of the class that has your server functions in it. The second one is the name of the class that has your client functions in it. And the third one is the name of the class that has your main functions in it. So if we come here to our DLL and we look in the scripts, we have client, GUI, server, and main. And if we look at this namespace, DNT FPS demo scripts main, and we come back here to main window, DNT FPS demo scripts main. If we come here to client and we just pick one of these clients at random, you'll see it's DNT FPS demo game DLL scripts client main. And if we come back here to our main window, you'll see DNT FPS demo game DLL scripts client main. So these tell .NET Torque to map this class to your C# DLL. So it knows how to pass, so it knows how to pass control between the T3D engine and C#. Then you have to say where is the DLL, and in this case I'm saying the name of the DLL is the DNT FPS demo game DLL.dll, and I pass that in. For non-dedicated mode, I need to pass in a handle to the window, and then the same parameters, what the name of the classes are, and the path to the DLL. And then I do some resizing here. And then we have debugging functions. So, for example, let's say we set this to true. Let's see what happens. Debugging's pretty cool. Launch dedicated, sure. So if we switch to output, what we're looking at, this is the output from the engine. Basically every time you set a variable, read a variable, or call an extern, or call a function, it gets logged into the output. So assuming that you're trying to chase something down or you're trying to optimize something, this gives you a little bit of. So in this case, we can say create AI. Let's just do 10. You're looking to see what's going on in the engine. Let's say you think you have some bad code, or you think you have something that's not optimized. This lets you see the call stacks, what's going on, who's getting called, so forth and so on. So if we come over here, we can see. Let me shut this thing down because that's a little bit much. So we go into here, FPS node core game console.log. You can see everything as it gets loaded.